As a producer and supplier of building materials, Etex Group is continually looking for opportunities to reduce its impact on the environment, and reducing CO2 emissions is an important aspect of this. The production process as well as the full supply chain is taken into account, including the selection and transport of raw materials. Rather than having hundreds of trucks transporting products on the roads, Etex Group has switched to using barges instead. Etex Group products have been used to create some of Germany's most sustainable buildings. For example, the Umweltbundesamt Sustainable Association building and the Paul Wunderlich House. The exterior of this construction is covered by a smooth, durable cement board developed by one of the Etex Group companies. These new boards are designed to be eco-friendly, and their manufacture does not release harmful emissions into the atmosphere. As well as addressing solutions for new buildings, one of the key issues is how to tackle the inefficiencies of existing constructions. 50% of Europe's housing was built before 1975. During a building's lifespan, its operation uses 80% of the associated energy, and this is primarily due to the lack of insulation. An estimated 70% of energy efficiency investments go towards double glazing. However, this only saves 10% of heat loss, compared to 30% for insulating the walls or roof.
We know that about 40% or even more than 40% of the CO2 emissions is coming from the heating of buildings. So the energy used to heat buildings is causing more than 40% of the CO2 emissions. So by insulating buildings in roofing and by adding cladding and insulation to buildings, you can substantially reduce the CO2 emissions.
Traditionally, insulating walls has involved complex construction work. Etex Group is solving this with an outer facade product that can be applied in thin, lightweight outer sheets. It is estimated that they will cut energy consumption by at least 50%. Fire protection and high thermal insulation is one of the most pressing issues in the building industry. Burning of construction material can release large amounts of hazardous substances and carbon into the atmosphere. Good fire protection means fewer buildings or parts of buildings will need to be renovated after a blaze. This results in less waste and requires fewer new products to be manufactured, saving both energy and resources. While Promat has championed the development of fire protection boards in recent years, one of the newer innovations has been fire-resistant glass.
We design our products to the minimum weight and the minimum thickness, thus avoiding the exuberance of material, and we use only the minimum materials necessary to guarantee the high performances we require, and therefore with a minimum impact on environment. The production of glass is a very energy requiring process, so we simply use as little glass as possible in order to guarantee the performances of our products.
As well as looking at short-term solutions, Etex Group is also looking to long-term innovations. Last year, Promat was involved in supplying high-temperature insulation products to build the world's first thermal solar power plant. The sun shines on a number of mirrors that reflect the sunlight to the top of the tower. The receiver is then heated up and reaches temperatures of more than 1,000 degrees centigrade. Air sucked in from the outside is heated up to 700 degrees centigrade, which is then used to produce water vapor. This steam drives a turbine connected to a generator to produce electricity that is clean and sustainable.
Thermal solar power plants use the sun to produce energy. So the sun will create steam. Steam will be running through a turbine and we connect to a generator. The perfect sustainable solution. In this process, high temperatures are involved, and Promat provides the solutions for high temperature thermal insulation. The same occurs for fuel cells, for example, which are environmentally friendly, but high temperatures are involved, and in the same moment Promat interferes with high temperature insulation solutions.
The overall question of climate change, which is like this huge subject which is hanging like a cloud, if you like, over everything we do today, and it's a very serious question, and obviously to contribute to a more intelligent use of resources and to try and avoid unnecessary emission of carbon dioxide is probably one of the most important aspects that we all have to contribute to.
I'm walking down the world's longest pedestrian system, the Strøget. Cutting through the centre of Copenhagen, this street is at the heart of the city's vibrant culture. Copenhagen is home to 1.8 million people, and in recent years has won a number of awards as the world's best city to live in. In 2008, British magazine Monocle described it as the planet's best designed city, and judging by the architecture and layouts around me, it's not hard to see why. When delegates arrive in Denmark this December, they will be landing in a country that is enjoying something of an architectural renaissance. One of Denmark's oldest architectural practices is C.F. Møller. 80 years after Professor Christian Frederik Møller launched the company in 1924, the multi-award-winning firm, now one of the largest in Scandinavia, has 7 offices located around Europe. C.F. Møller has always regarded social responsibility and innovation as a core part of its work.
We have 3 basic reasons to work with environmental policies. The first reason would be the ethical one, which is really it's good to do good, and we want to help. And as I said, it's in the prolongment of our own natural tradition. And the world needs a big paradigm shift anyway, and we want to be there to help. The second reason would be the artistic reason, because developing new architectural styles and systems is very obvious when you work with the new sustainable architecture or green buildings, if you like. And this is very exciting and highly motivating and interesting for creative minds, as architects have. The third reason would be the commercial reason, because we know for a fact that sustainable architecture is here to come. It's the future, really, and we have to be there, and we have to be ready to supply.
To ensure continued best practice, the company has introduced an environmental management system. As 40% of all energy consumption comes from buildings, the company's target is the creation of plus energy buildings, those that produce more energy than they consume. One such building is the Akershus University Hospital. Opened in November 2008 in Oslo, Norway, the hospital claims to be the most modern in Europe. Its design allows for daylight in all workplaces, views of the surrounding countryside, as well as contact with the environment. A glass-covered main thoroughfare in which wood is the dominant material links the various buildings and functions. A deep geothermal energy well provides 85% of all the heating needed in the hospital, which helps it reduce its total energy consumption by 40%.
There are several studies that show that if you do a healthy office building, for instance, you can obtain up to 10% more efficiency out of the workers working there for the healthy, non-toxic environment. And you have less absentees. And we know for a fact that if you are hospitalized in a green building, a green hospital, you will get well a lot quicker. And as the last good example would be if you score higher marks and do better tests in school, if your school is a healthy building.
Another of the company's projects is an environmentally sustainable villa on the shores of the Wadden Sea in Denmark. Villa Ulstrup converts used energy into new energy to sell back to local power companies. The large windows facing the view to the southwest make the best passive use of the sun's heat.
This villa is a perfect example of what we would call energy design. So beginning the process, we'll be looking into how is the orientation of the site, what are the options energy-wise, what technique can we use, how can we best build this building to respond to the energy demands and to respond to the qualities of the site as well. So we have a sketching process initially, finding out how to optimize these different factors, and this creates the shape of the villa, and then comes in the technique of the building, how it's going to be constructed, using prefabricated materials, using thermal mass, using renewable energies, and so on.